Okay, I had ISS, so I couldn't finish the notes from 11.2, so these are the rest of the notes. I know I left off at the part of trying to find the velocity and acceleration, and I think when I ended, I found the velocity of 3 cosine of 3t and a negative 5 sine of 5t. If you remember, the position I gave you was sine of 3t cosine of 5t. So to find the acceleration, I just take the derivative of that. The derivative of cosine is a negative sine. I leave the inside alone, then I take the derivative of it, which makes a negative 9. The derivative of sine is cosine. Leave the inside alone, take the derivative of that, which makes 25. The next part is just giving you another example of it. A particle moves in an elliptical pattern. Elliptical looks like this. A particle moves in an elliptical path where the position is 4 sine of t, 2 cosine of t. They want you to do A, they want you to find the velocity and acceleration, and B, they want you to find the velocity, acceleration, and speed at pi over 4. Okay, so first thing I'm going to do is I'm going to find A, the velocity and the acceleration. Okay, so the derivative of sine is cosine, and you just carry the constant. The derivative of cosine is a negative sine, so it's a negative 2 sine of t. And then I'm going to do acceleration. The derivative of cosine is a negative sine, so it's a negative 4 sine of t. And the derivative of sine is cosine, so it's just a negative cosine of t. So I'm done with the A. I found the velocity and acceleration, and now I'm going to find it at pi over 4. So all I'm going to do is, in place of my t, I'm going to put pi over 4. So pi over 4 is 45 degrees, and it looks like this. So I'm just going to substitute. I want to go 4. Whoops, sorry. I'm going to do 4 times the cosine. Cosine is the square root of 2 over 2. I don't know why I put that. And a negative 2, and the sine is the same, square root of 2 over 2, which equals, 2 goes into 4, 2, so it's 2 square root of 2. And the 2 and the 2 cancel each other out, so you get negative square root of 2. Final answer. To find the acceleration, you do the same thing. Acceleration, it's a negative 4 times the sine of the square, it's the square root of 2 over 2, and it's a negative 2 square root of 2 over 2, which gives you 2 goes into 4, negative 2, so you have a negative 2 square root of 2. 2 goes into 2, negative 1 square root of 2. And the last one, they want you to find the speed. Speed is the absolute value of v, but absolute value of v really means the length. So all I'm going to do is the square root, and all I'm going to do is take the square root of 2 square root of 2 and square it. I'm getting it from right here, plus a negative square root of 2, and I'm going to square it, which equals 2 square root of 2 squared is 8, plus 2, which ends up being the square root of 10. Final answer. Okay, the next part is just going over, okay, I showed you how to do the derivative for the velocity and the acceleration, and now I'm just going to talk about displacement, which is integration, and distance traveled. This all deals with integration, right? So, I showed you how to find the velocity acceleration of a vector. Now I'm going to show you how to integrate. So, if you are given, I'll give you the displacement formula first. You're going to integrate from some a to b, some vector 1 t dt. And then the other one is going to be from a to b, vector sub 2 of t dt. Okay, that's how you find the displacement of a vector. And how do you figure out total distance traveled? You integrate from a to b, the absolute value of v sub t dt. So, I'm just going to give you one example on how to do displacement and distance traveled. So, here we go. V sub t is equal to t minus 3 pi cosine of pi t, and 2t minus pi sine of pi t. Okay, so that's the vector that they give you, and they want you to find, and obviously v means velocity, they want you to find the position, so they want you to integrate, because that was the velocity, at t equals 4 if the initial position, there's that, remember that little key thing that you had in calculus AV, if the initial position at t equals 0 is 1 comma 5. So make sure you don't forget this small little detail at the end. So all I'm going to do is I'm going to integrate from 0 to 4, and I'm going to integrate the t minus the 3 pi cosine of pi t. And I'm also going to integrate from 0 to 4, 2t minus pi sine of pi t dt. Forgot my little dt again. So, we are going to get, when we integrate this, I don't know if they used the calculator or if they did it the long way. Let me just look really quick in the book to see if they did it the long way or if they actually used the calculator to solve this. To me, it looks like they just used the calculator and they got the answer. They got 816. Just to kind of give you a heads up, how would you integrate t? It would be t squared divided by 2. This one, you would probably have to go up here and use substitution. I guess I could integrate it. It's the antiderivative of cosine, which is sine, and then you leave it at pi, and then you leave this as 3 pi, and then you take the derivative of pi, which ends up just being that. So, with the t. Just use your calculator to do this, and they got 816, but that's not the final answer. The final answer to this problem is 921, because I had to add 1 and 5 to the final answer. So in order to come up with this, just use your calculator. Your calculator will figure out this one first, and it'll get 8. Your calculator will figure out this one, and will get 16. To find the total distance traveled, you're going to integrate from 0 to 4, And all you're going to do is you're going to take the square root of the first part, which is t minus 3 pi cosine of pi t. You're going to square it. Plus, you're going to take 2t minus pi sine of pi t. And you're going to square it. And again, they use their calculator to find the total distance traveled. It ends up being 33.533 out to 3 decimal places. On page 549, I just want you to look over example number 6. I just want you to read over catching a fly ball on page 549, number 6. Catching a fly ball. Read through that one. They want you to find the position, which means you have to integrate. They want you to find the velocity, and at what time does t. So just kind of follow that and see if you can follow how they got the answer. So, okay, that's the end for vectors, which was 11.2.